compared to 51 out of 159 in the haloperidol group? What would the appropriate test be? In this case, don't shout it out, think about it. So the data that we have says, after 1 year, 61 out of 163 patients in the clozapine group showed clinically important improvement in symptoms, compared to 51 out of 159 in the haloperidol group. Now, do we have an answer in mind? Okay, so what test would we use here?
Confidence interval, P?
It would be the chi-square test for independence. Okay, we have two. What is our response? Our response is whether they showed improvement in symptoms or they did not.
Mm-hmm.
Okay, did they show improvement in symptoms or not? That's the response. And we have two different groups, categorical predictor. Those who got clozapine is one group, and or those who got haloperidol is the other group. So we have a categorical response. Did they improve or not? And we have a categorical predictor. Were they given this drug or the other drug? So we have categorical response, categorical predictor. We're going to be doing the chi-square test for independence. Okay. If we only were talking about one group, then we could do a chi-squared, confidence interval for P. We could do that. But that's only if we had one group. But here we've got two groups, so we have a categorical predictor.
What do you mean by known predictors for the categorical?
No predictors.
Yeah, what does that mean?
That could be like you just want to know, you have some proportions in mind. So, somebody could say, oh, I don't know, the military has too many men or something. And they say, if you look at it, it's like 95% male or something, and only 5% female. And somebody says, oh, no, that's actually not right. If we looked at the military, it's closer to 82% male or something, okay? And so we would take data, and we would see whether the proportion's 95%, 5% fits the data, or how good is the fit of the data there. So we don't have a predictor there. We just have some proportions in mind. Okay? Yes?
So I'm looking at the sheet on the website, and it says no predictors. It says no two categories. So how does that?
Oh, so yeah, the two categories here for P regarding that would be like, it's kind of like the binomial distribution. We have P for probability of success, and we treat everything as success or failure, okay? Meaning either it's in this group or it's not. So that's what we mean by two categories. It's either in this category or it's not. We don't actually care about any further details than that.
So the two groups, they have a called predictor, is that right? When it's two groups.
Yes, if you have two groups, that's going to be a categorical predictor.
And if it's only one group and you're deciding something about that one group, then you use one or the other.
I feel like this question, if there's only one group, I don't think that we're ever going to be in a situation where we have.
I'm just trying to figure out how to separate.
Okay, we'll see an example. All right, we'll try more examples. Okay. All right, so I'm going to skip to 13.2.3. All right, it says a biologist collected data on the height measured in inches and peak expiratory flow a measure of how much air a person can expire measured in liters per minute for 10 different women. And it says here are the data, and it says subject 1, height 63 inches, peak expiratory flow 410 liters per minute, and the data goes on. Okay, we have these measurements for things, and we want to know, is there a relationship between height and peak expiratory flow? Okay, so in that case, which statistical method would we use there? Don't shout it out, but think of your answer. Okay, what do we think our answer is? Correlation. Correlation to regression. We have a numeric response and a numeric predictor. Okay? So we want to see, peak expiratory flow, the numeric response, is that related to the height of a woman, the numeric predictor? Okay, so we haven't covered that yet, but that's what we will be learning next week. 2 numeric variables correlation. It's a little tougher than you might first think.
So, in this question is, so could you say that the EF is the numeric response and the height is the predictor?
It seems to make sense that way, but if you flip it around, it's an equally valid question. Okay? It's equally valid, either question. Yes?
Can you just give like a general definition for response and predictor?
Response is generally the thing that you're interested in, and the predictors are usually the variables that you're interested in seeing if they affect the response. Okay? So response is generally the thing that you want to measure, and the predictors are the things that you want to see if they have an influence on the response. General.
Did you say it was the inference, was the response?
What have an influence on the response would be the predictors. So we would say, so the general idea is that predictors would influence the response. Yeah.
Are your response the results or outcomes?
The word results and outcomes are a little too big for me to give you a comfortable answer. What do you mean by that?
Like the numbers that you're generating, like in a study. So those are not your responses.
When I hear outcomes, I generally think the conclusion of the study,
Oh, okay.
and not, and response would be like the values that you are recording when you're taking data. The results when you're gathering your data. Okay, that would generally be your response.
In this example that we just did, is the height the predictor?
It would seem that we would use height as predictor and peak expiratory flow as the response. It would seem that way, but it is equally valid to flip the question around. Generally, we treat height as this thing characteristic of a human that we can't do anything about. And so we generally would say things don't influence the height. So that's generally what we say, but it's not wrong to use it the other way. There's nothing inherently bad about that. People might raise their eyebrows, but in terms of the statistical analysis, there's nothing incorrect about it. Okay. Although if you look at 13.2.4, it talks about Maria and Annika and how Maria is an inch taller than Annika, and how would that change your prediction of someone's peak expiratory flow. And in that case, it's clear that height is the predictor. Okay, so let's look at 13.2.5. And it says, a geneticist self-pollinated pink-flowered snapdragon plants and produced 97 progeny with the following colors: 22 red plants, 52 pink plants, and 23 white plants. The purpose of this experiment was to investigate a genetic model that states that the probabilities of red, pink, and white are 0.25, 0.5, and 0.25. Identify the type of statistical method that is appropriate for this data. Okay, so again, think about this, don't shout it out. Okay, well, what do we do here? Chi-squared goodness of fit. Okay, chi-squared goodness of fit. So here we are just looking at the color of the flowers, red, pink, or white, but there's no predictor here. Okay, we just had proportions in mind, saying that red should show up this often, pink should show up this often, and white should show up this often. Right, so we have just proportions in mind. I'm going to skip over to 13.2.8. And here it says, biologists were interested in the distribution of trees in a wooded area. They intended to use the number of trees per 100 square meter plot as their unit of measurement. However, they were concerned that the shapes of the plots might affect the data collection. To investigate this possibility, they counted the number of trees in a square plot, round plot, and rectangular plots. The data are shown in the following table. Okay, so they're measuring the number of trees within a plot, and then they're looking at whether the plot is square, round, or rectangular. And and they have numbers listed there. So square, it's like 5, 5, 5, 8. Round, 5, 7, 5, etc., etc. So we want to know what test is appropriate there. ANOVA. We have a numeric response, number of trees within a plot, and we have a categorical predictor, whether it's square, round, or rectangular, and we have more than 2, so we're going to be using ANOVA. Okay. All right, one more. 13.2.10 says a sample of 15 patients were randomly split into 2 groups as part of a double-blind experiment to compare 2 pain relievers. The 7 patients in the first group were given Demerol and reported the following numbers of hours of pain relief: 2 hours, 6 hours, 4 hours, 13 hours, 5 hours, 8 hours, and 4 hours. And then 8 patients in the second group were given an experimental drug and reported the following numbers of hours of pain relief: 0 hours, 8 hours, 1, 4, 2, 2, 1, and 3. How might these data be analyzed? Okay, so we're measuring number of hours of pain relief. 15 patients were randomly split into 2 groups, double-blind experiment to compare 2 pain relievers. Okay, so I would argue we would just a simple t-test for independent groups. Okay, if you want to use the Wilcoxon-Mann-Whitney, that's not inherently wrong. Although I would not say there's any significant outliers in either group. Maybe one could argue that the 8 in the second group is an outlier and maybe an indicator that we should use Wilcoxon-Mann-Whitney, but I would. That's possible, but maybe, maybe not. And then in the first group, I would, there's quite a bit of variation but I wouldn't say any of those are really huge outliers either. So, you know, if you feel like there's outliers, maybe Wilcox and Whitney. If not, you can chance it with a t-test.
How's it a numeric response?
It's the hours of pain relief, okay?
Hours.
Yeah, so it's just the number of hours. Okay.
It's not considered a small sample?
It is a small sample, okay? So it is a small sample, but the small sample is not a problem if you can assume that the central limit theorem holds, okay? If you feel like that 8 in the second group is an outlier, maybe you would say we should use the Wilcox-Whitney test.
What about the 13, because between 2 hours and 13 hours is quite a jump.
I guess, but then there's also an 8, and so, you know, so what would the IQR be? The IQR would be about 1, 2, 3, 4, 5, 6, 7. Yeah, it'd be hard to do an IQR here. What would 8, 4, 1.5, 6. Yeah, so if you did 1.5 times the IQR there, I would think it would take you out to around 14. So then 13 would not seem like an outlier. Whereas in the other group, the IQR is probably like 3. Yeah, so 1.5 times the IQR above Q3 would take you around to 7.5, 8, 8.5, something around there. So it's hard to do an IQR when you only have 8 people and stuff, but it might give you an 8. Okay, well, that might be it for today's section of review. Okay, learning which test is appropriate in each scenario. Okay, we'll see you guys next week. Yes.
This is for the final, not.
The final exam, yeah, not for the quiz next week. Okay, next week's quiz I have detailed out on the homework page.